Hello and welcome to this video. In this video we're going to be looking at the topic of phase and interference. So we've already done a video looking at what phase is and how phases can cause things to change. Now we're going to look at what happens if we have two waves with maybe different or maybe the same phase and see how they would combine. So how are they going to interfere? So just to recap what we looked at on phase, we said that if things have a phase difference of 0, 2 pi, 4 pi, 6 pi, so on, any even integer of pi, then they are in phase. And if they are pi, 3 pi, 5 pi, 7 pi, any odd integer, they're in antiphase, and anything else is just out of phase. Okay, so this now we can say, I'm going to set up some axes and I'm going to look at how things behave when they're in phase and how things behave when they're in antiphase, and then how things might behave if they're just out of phase. Okay, so let's first look at what happens when things are in phase. Okay, what that means is if I set up some axes, so just to allow us to see the kind of thing that's happening, I'm going to draw the first wave in red, and the first wave is going to be a sine wave, and my second wave is going to be in blue. My second wave is exactly in phase with this, which means it is 0 phase difference apart, so it exactly overlaps this red one. Now I can't obviously draw it to be an exact overlap, but you get the idea. They are essentially the same wave, just doubled, and that's exactly what we're going to do. When we have two things that are in phase, the way they interfere is called constructive interference. Okay, so the way waves interfere is they do a thing called superposing. Okay, so they superpose. I'm going to put this word underlined because this is a very important word in this whole thing. In some questions where we're going to look at the formation of stationary waves, just for writing the word superpose, you'll usually get a mark just for the word and nothing else. So it's a very important word. So what's happening here is called the superposition of two in-phase waves. Okay, so how we would describe constructive interference is that two waves that are in phase superpose, and I'm going to put that underlined again, and what happens then is when they superpose, they interfere with each other. When they interfere, they essentially just combine to make one resultant wave. Okay, this resultant wave I'm going to draw in this white color, and what's going to happen is we essentially add all of their displacements, all of their y values. And so if I have this point here where they're both 0, if I do 0 plus the 0, I still get 0. So this point doesn't change. This also means that this point isn't going to change, and neither is this point. But when I get up here, which is its maximum amplitude A, up here, they both have A, so I'm going to add them together and get A plus A, and so I'm actually going to have to make more space because that is just going to double the amplitude of this wave. Okay, so if this is A, then this distance is 2A. Now this obviously doesn't look very accurate, but this is when you draw it in your exam, you'd want to make it more accurate, and it'll usually be on a grid, so you could do that by counting the amount of squares. And so what happens is this is called constructive interference because you're building the wave up, you're making the amplitude bigger, which means that we know that amplitude squared is proportional to the power. So if we have a much bigger amplitude, it means that we're transferring much more energy per second, which means that we've now got a stronger wave. So if this was light, for example, it'd be much brighter light. So the two waves that are in phase superpose and sum to form a larger resultant wave. Okay, this is the idea of constructive interference, is just that we can have two waves that are in phase with each other and they will add together to make a much bigger wave. Now let's look at what happens when things are in antiphase. Okay, so this is constructive interference. I'm going to keep that there. Now let's have another graph down here. Okay. Now I'm going to do the same thing. First wave is going to be in red, and I'm going to draw it identical to what we just did. Now, if the second wave, which is the blue wave, is now in antiphase with it, it means that it's pi difference, which means that this point here actually starts here. And so I'm going to start it by doing this. And then because I know this is going to be a continuous wave, it would eventually trace backwards and do this. Now, you can probably assume what's about to happen here. If I'm going to add together all of their points, and this is always, if this is plus A, this is minus A, so when I add these two things together, I'm going to get 0. And what you'll find is that when two waves are in antiphase, they will always add together to get an exact 0 wavelength. Okay, so your resultant wave will be nothing. It will just be this wave along here. Okay, this is called destructive interference. Okay, so constructive interference is when they're in phase. We build up interference. When they're constructive, we build the wave up. When they're destructive, we break the wave down into a smaller wave. Okay, so two waves that are in antiphase superpose, so they're still combining, and sum, because we're still adding, but we're adding a positive and negative number to produce a no light, or let's say no resultant wave, because this could span to be many more things. So two waves that are in antiphase superpose and sum to produce no resultant wave, meaning that this phenomenon means if we have two light rays that are traveling and they form an antiphase relationship, we can actually cancel out the light and get no light at all. We could do the same thing with sound. We can do the same thing with any wave. And we'll look, these are the two main important things, and we're going to look at these, and they're going to help us to explain stationary waves and also diffraction. But I did say we're going to also look at something that's just out of phase. So let's just do that one quickly. This one's going to be a little bit stranger. So I'm going to draw a bigger graph so we can get a better idea of what's actually happening at each point. Okay, so this is, let's start with the same initial wave. Okay, so we're still going to start with a red sine wave. But our blue wave is going to be just out of phase, so it can't be 2 pi or pi, it just has to be somewhere in between. So what I'm going to say is let's just have it as pi over 2, and that way that we start here, and so we're going to get a wave that comes up to a maximum when this is there, and then it's going to come back down to a minimum here, and then back down to a minimum down here, and then down to a minimum here. So it's going to trace through these dots. Okay, so we've got the same wave, we've just shifted it along by pi over 2 by a difference of pi over 2 out of phase. Okay, now we're going to do exactly the same thing we've done, but you'll find that in some places when things are out of phase, you'll get constructive interference, while in other places you'll get destructive interference. For example, here we're adding a 0 and a minus a, so this is going to become minus a, because minus a plus 0 is going to give you minus a. Okay, this point here is going to be 0 plus a, so that point is going to be a. This point here is 2 positive, so we're going to find whatever this point is and we're going to double that, because that's going to have some sort of constructive interference between these two. Then this point here is going to be here, because this is the amplitude plus 0, so we're not going to go anywhere. This point here is going to be the amplitude at the bottom here. These 2 points are going to constructively interfere to make a larger amplitude here, and then these 2 points are going to make it here. Okay, so what's actually going to happen with this wave is we're going to go up to the very top, come down to the bottom, and then we're forming a larger wave. Okay, and what you'll find is if we carry on doing this, this will continue on to go down, and it will construct a larger wave. So we might say that this is totally constructive, but there are positions along this wave where we have destructive interference, because we'll get places where, like in this region here, we have positive values of the red wave, and we have negative values of the blue wave, so they're actually cancelling out here to make a smaller amplitude than what should be. So in this region we actually have destructive interference, in this region we have constructive interference, then we have destructive here again, then constructive, and we keep going like that. So when we have things that are just out of phase, they can have a mixture of having both constructive interference and destructive interference, and this is when we get kind of weird waves. We don't focus on these too much at A level, because they're not really anything special or interesting about them. So we're just going to focus on looking at what happens if we were to have pure constructive interference and pure destructive interference, and how that's going to affect the light that we're going to look at, or the waves on a string that we'll also look at. So this is interference. Thank you for watching.